Welcome back, everybody, for another deep dive. This time we're tackling image recognition and how it all really works.
Yeah, we've got some really cool insights from this tech podcast, 9 Minutes, to help us unpack all that.
Right. It feels like every day there's a new headline about some mind-blowing thing AI can do.
Like computers learning to see, right?
Exactly. See? I mean, that was basically science fiction a few years ago.
It was, and honestly, even understanding the basics can feel kind of sci-fi still.
Okay, so then let's start there. Like, how does a computer even see an image in the first place?
Well, we humans, we look at a sunset, we see all those vibrant colors, the beautiful scenery.
Right, but a computer doesn't see it that way at all, right?
Exactly. To a computer, a sunset, it's just this grid of numbers. Each number represents the color of one tiny little square, a pixel.
So like thousands of pixels making up the whole image.
Millions even. And
Yeah.
each one's just a number. So think about it, like, how would you describe that sunset to someone who's only ever seen numbers?
That's a great analogy, right? Because that's basically what we're doing with image recognition, somehow teaching computers to make sense of those numbers, those pixels.
Yeah, and that was, the first big challenge researchers had to figure out.
Okay, so then how'd they do it? How do we get from just a grid of numbers to, like, a computer actually recognizing, say, a dog versus a cat?
That's where machine learning comes in. Imagine, you're teaching a toddler what different objects are.
Right, like pointing at things, saying dog, cat, ball, over and over.
Terrific. You're showing them tons of examples, patiently labeling each one, and slowly they start to pick it up.
So we're basically doing the same thing with computers, just on a way bigger scale.
Exactly. We train these machine learning models using massive data sets of images, thousands, even millions of them, all carefully labeled, like this picture is a dog, this one's a cat, this one's a car.
And the computer just gobbles up all that data.
Gobbles it up and starts to look for patterns, right? Like, what are the features that distinguish a dog from a cat based on the pixels, the numbers?
Makes sense, but like, the real world's messy, right? Think about taking a picture. The lighting's different every time. The angle might be weird. Things are partially hidden behind other stuff.
You got it. Tons of variation, and that's where those basic models start to struggle.
Okay, so is that where deep learning comes in? I hear that term everywhere.
You got it. Deep learning, and specifically these things called convolutional neural networks, or CNNs.
The CNNs. Yeah, I've heard of those, but never really understood what they are.
Well, they're much better at dealing with all those real-world imperfections, those variations.
Okay, but still, CNNs, they sound pretty complex. How do they actually work?
Think of it like solving a jigsaw puzzle, right?
Mm-hmm.
You start by looking at individual pieces, figuring out their shapes, the pattern.
And then slowly you start fitting those pieces together, seeing the bigger picture emerge.
Exactly. CNNs work similarly, but with images. They break down the picture into smaller sections, then analyze each one, looking for certain patterns.
So instead of puzzle pieces, it's like analyzing chunks of pixels.
Yeah, and then it combines all those little analyses to understand the whole image.
So, like, that's how my phone can recognize my face even if I'm wearing sunglasses. It's not just matching a photo, it's looking for those underlying patterns.
Right, exactly. CNNs have been huge because they let computers see beyond the surface, to the essence of what an object is, kind of like we do.
That's amazing. So we've gone from pixels to patterns and these powerful CNNs. Where does this all actually get used, though? Like, what are some real-world impacts of this tech?
Oh, tons of places. I mean, one you probably use every day is facial recognition, like unlocking your phone.
Oh, right. Yeah, I never really stopped to think about how that actually works. I just figured it's like taking a picture and seeing if it matches, right?
Well, it's more sophisticated than that. When you set that up, your phone scans your face, but it's not taking a snapshot, really.
Okay, so what's it doing?
It's analyzing specific measurements,
Yes.
like the distance between your eyes, how your jawline is shaped, all those unique contours.
So it's making like a numerical fingerprint of my face. Is that it?
Exactly. And that's what gets stored. It's like a unique numerical representation, kind of like a face map, just for you.
And then every time I unlock my phone, it's creating a new map, comparing it to that original.
You got it. And if they match, boom, you're in.
That's wild. But, okay, what about applications that need to recognize way more than just faces? Like, self-driving cars come to mind. They have to process so much visual information constantly.
Oh, yeah. Self-driving cars are a perfect example of how complex this has gotten.
So, how do they use image recognition?
It's a whole system, right? Cameras, sensors, and then, powerful image recognition algorithms working together.
To understand everything around them, I guess.
Exactly. Road signs, lane markings, pedestrians, cyclists, other cars, all of it.
And it's got to be happening in real time. That's got to be some serious processing speed.
Oh, yeah. The speed is incredible. A tiny delay could be dangerous. And that's where specialized hardware comes in, things like GPUs.
GPUs, like the ones in gaming computers.
Yeah, same idea. They're designed to handle tons of data all at once.
So they can keep up with all that image data from the car's sensors.
Exactly. They can process information in parallel, so it's perfect for something as demanding as real-time image recognition.
Okay, so we've got phones unlocking, cars driving themselves. Where else is image recognition having a big impact?
Oh, it's spreading everywhere. Healthcare, for one.
Really? How so?
It can help doctors analyze medical images like x-rays or scans to spot things that are hard to see.
So like a second pair of superpowered eyes able to pick up on tiny details.
Totally. And way faster than a human could.
Right.
It's already being used to detect tumors, find signs of disease, all sorts of stuff.
Wow, and is it just healthcare?
Nah, retail's getting in on it too. There's this thing called visual search starting to pop up.
Visual search, what's that?
Like, imagine you see someone wearing an awesome outfit, right?
And you want to find something similar.
Exactly. You take a picture, and the search engine finds similar items from all over the web.
That's amazing. No more trying to describe things with words, just snap a photo and you're done.
Exactly. And those are just a few examples. Security systems, agriculture, disaster relief, it's being used everywhere.
It sounds like the possibilities are truly endless. We've gone from pixels to patterns to all these real-world applications. It's incredible.
Yeah, it really shows you how impactful image recognition already is. And it makes you wonder, where does it go from here? What's next? Yeah, it really is remarkable to think about how far we've come in such a short time.
Feels like we went from science fiction to everyday life practically overnight. So what's the biggest takeaway? What do you hope people get from this deep dive?
I think the most important thing is realizing that image recognition, it's not just about like fancy gadgets and futuristic stuff.
Right. It's already here, impacting our lives in a big way.
Exactly. Making things faster, more efficient, more accurate, and it's only going to get more prevalent,
Yeah, it feels like we're just scratching the surface. What areas do you see image recognition having a particularly big impact on in the future?
Oh, well, healthcare is a huge one. The potential there helping doctors diagnose, personalize treatments, improve outcomes, it's incredible.
Right, like we talked about earlier, those super-powered eye-spotting things humans might miss.
Exactly. And when you combine image recognition with other advancements in AI, things get really interesting. Imagine, algorithms that analyze medical images, genetic data, lifestyle info, all together.
To create personalized healthcare plans. That sounds almost too good to be true.
It does, but it could be reality sooner than we think. And beyond healthcare, transportation, making cities smarter and safer, even how we interact with the world around us.
What do you mean by that last one?
Imagine walking down the street and your phone instantly identifies landmarks, businesses, even friends you might bump into, all through image recognition.
That's wild. It's like giving everyone a superpower.
In a way, it is. It's giving us this new lens to see and understand the world. And as the tech evolves, who knows what other amazing applications we'll find.
I'm definitely excited to see where this all goes. It's been a fascinating deep dive into the world of image recognition. Thanks so much for sharing your expertise with us.
Oh, it's been my pleasure. Always happy to talk about this stuff.
And for our listeners, we hope you found this exploration as insightful as we have. If you're eager to learn more, be sure to check out the show notes for links and resources. Until next time, keep exploring and stay curious.